Okay, so in this video, I'm just going to show a few examples of how to write an ellipse in standard form, and I think it's easiest if I just show you like what I'm going to be doing. So I have these equations here. So I've covered in other videos, right, like how the standard form looks, and these are clearly not in that standard form. And so we've talked about using completing the square in other videos, and we're just going to use that here as well. But I just wanted to have a couple of examples in case you needed a refresher on that. So, okay, so I have this equation that's an ellipse. So how would you even know just by looking at this that this is an ellipse? So there's really like a huge hint, two huge hints. One, you have x squared and y squared. Two, both the x squared and the y squared are positive. So like that's kind of the key thing for having an ellipse when you have both the x squared and the y squared positive. Okay, so we want to use completing the square here. So what we're going to want to do is we're going to want to put the x terms together and the y terms together. And then from here, so we want to have just a squared term. So this one is good. This one has a problem with it being 12y squared. So what I'm going to do is I'm going to factor the 12 out. And you'll see why in a second. So if I factor the 12 out, that's going to give me y squared minus 4y. Okay, so the reason I did that is because we can't complete the square unless we have just y squared or x squared. So this allows me to complete the square, but by putting the 12 in front here, this is going to create a little curveball for the problem, but I'll show you how to handle that in a moment. So let's start with the x's. So to complete the square here, so hopefully by this point, like you feel pretty comfortable completing the square. So my b in this case would be negative 14, and then I go through all the steps for this, right? So my half b is negative 7, and my half b squared is 49. Okay, so that's one. Let's do this one as well. So for this case, my b is negative 4, my half b is negative 2, and my half b squared is 4. Okay, now normally with completing the square, we want to add these numbers into the parentheses or to these x's and y's respectively. So let's start by doing that, and then I can kind of show you the curveball with this. So I've got x squared minus 14x, and then plus 49. Okay, so that's for 1. That's for my x's. And then I've got plus 12. This will be y squared minus 4y plus 4. Okay, so on this side, I got to keep the equation in balance, so I'm going to add 49. But here's where the curveball comes in. I'm not just going to add 4, so I need to respect the fact that there's a 12 in front here. So what I'm going to do to this side is I'm going to add 12 times 4. So that's now taking this 4 and just bouncing it off of the factor in front here. Okay, and so that's kind of the curveball, I guess, with completing the square that I wanted to show you. So now we need some more space, so I'll make some room. Okay, so now I think the rest of this you can probably take a guess as to what to do. So for the x's, now I want to, oops, let me get the white color. So for the x's, I want to write this now as x minus 7 squared, so write it in its factored form. And then here I've got 12, and this is going to be y minus 2 squared, and then this is going to equal on this side 12. So now this almost looks like an ellipse, but we know with an ellipse with the standard form, we have everything we have everything over like a fraction, right? And this is usually equal to a 1. So the last thing that I want to do then is I just want to divide every part of this equation by 12. And now check it out. So I've got x minus 7 squared over 12 plus y minus 2 squared. I'm going to write this over a 1. I know I don't need it, but I like having it for ellipses just so I can like visualize like how I want to count this out. Okay, and this is all that we needed to do with this equation was put it into the standard form. So that's it, we're done. Okay, so I have another problem here. So just to be clear with this, so your best practice is always to isolate the variables to one side. So bring that 292 over to the other side. But what I want to do now is I want to challenge you to finish this problem on your own. So you just watched me do an example. Remember, math is not a spectator sport. So I think the best way to understand this is if you give this a try. And if you get stuck, oops, and I forgot the Y here. If you get stuck, no problem, right? But the answer will be more meaningful to you if you've thought about it for a second. So hit the pause button, hit play when you're ready. Okay, so similar, logic to last time. First, I'm going to factor out those numbers. So factor out the 9, factor out the 16. And then we can get the party started. So I'm going to complete the square here. So my b is 4, my half b is 2, and my half b squared is 4. And then here, my b is negative 10, my half b is negative 5, and then my half b squared is 25. And okay, so now here's where we have the goofy thing. So let's see. I'm going to take that half b squared and put it in here and do it again. Okay, so then plus 25, and I'm running out of space, but that's okay. So I'm gonna have negative 292 plus what? This will be plus 9 times 4, right? Because I have to bounce this 4 off of the 9, and then also plus 16 times 25, because I have to bounce this off of this. Okay, and now I think we're good to go, so I can clear some space. Okay, so now I can factor. So this is x plus 2 squared. This is going to be y minus 5 squared. And then this side will be 144. So now I just divide all sides by 144. And so I've got x plus 2 over 16. I've got y minus 5 squared over 9, and I've got all of that's going to equal 1. And so there you go. So there are 2 examples of how to complete the square so that you get the equation of the ellipse. So I will leave it at that, and I'll catch you guys